Okay, welcome back. For this section, we're going to focus on solving rational equations. And if you remember, there's two types of rational equations. Number 7 illustrates the type where we've got a single fraction set equal to a single fraction. Our strategy there was to cross multiply and solve. And then the other type, represented by 5, 6, and 7, is where there's multiple fractions on one side of the equation, or possibly both, in which case we want to multiply the entire equation by the least common denominator. So in number 5, we're going to have to multiply the entire equation by the least common denominator. So first thing I want to do is to factor all my denominators in order to identify that least common denominator. So on this very right-hand fraction, we notice that we have an x plus 4 times an x minus 4. And so therefore our LCD will be x plus 4 times x minus 4. Now, what I like to do is, at this point, I like to identify my restrictions, just so I can keep an eye on those at the end, so I know that x cannot take on a value of plus or minus 4. So I'm going to multiply this entire equation by the LCD, x plus 4 times x minus 4. Okay, this one I'll do out, and I'll go ahead and show what we would do there. So we would have x plus 4 times x minus 4 times 2 over x minus 4, and that equals x plus 4 times x minus 4 times 1 over x plus 4, and then minus 3 over x plus 4 times x minus 4, and that's being multiplied by the LCD, x plus 4 times x minus 4. Okay, so now I can cancel in the first fraction on the left the x minus 4's, and so I have to just distribute the 2 times the x plus 4, and that equals, I can cancel out the x plus 4's, and so I just have to essentially distribute the 1 times the x minus 4, which obviously would just be x minus 4, and in that far right-hand fraction, I can cancel out everything, so I'm just left with a minus 3. So if I clean this up, 2x plus 8 equals x minus 4 minus 3, or 2x plus 8 equals x minus 7, and we find that x equals negative 15. Now, that is not one of the restricted values. Okay, so seemingly it's a good answer. What we're going to do is we're going to take that back to the original problem, plug it in, and check our work, and we find that x minus 15 does work. So that's our solution. Okay, same strategy on number 6. First factor the denominator, so x plus 6 times x minus 5, and so my least common denominator will be x plus 6 times x minus 5. That represents all the factors in the denominator. Restrictions, I know that x cannot take on a value of negative 6, nor can it take on a value of positive 5, so I want to be on the lookout for those. I'm going to multiply the entire fraction by that LCD of x plus 6 times x minus 5. So if I distribute that in the first fraction, I can cancel out the x minus 5's, so I'm left with 5x times x plus 6. In the middle fraction, I can cancel out the x plus 6's, so I'm left with 4 times x minus 5. And in the right-hand fraction, on the right side of the equal sign, everything cancels out in the denominator, so I'm just left with the 54x plus 5. Okay, so now I'll distribute through here 5x squared plus 30x, plus 30x plus 4x minus 20, and that equals 54x plus 5. All right, looks like we have a quadratic, so I will set it equal to 0, so 5x squared. I'm going to subtract 54x from both sides, so minus 20x and minus 25 equals 0. I could pull out a 5, and I'm left with x squared minus 4x minus 5 equals 0. And so I have 5 times x minus 5 times x plus 1 equals 0. I could divide both sides by 5 and that goes away. And so I'm left with x equals 5 and x equals -1. Now, the 5 jumps right out at me because I remember that that is one of the restricted values that we identified earlier, so I got to automatically get rid of that answer. -1 is not a restricted value, so that is a legitimate solution. I'm going to plug that into check, and lo and behold, we'll find that it works. So therefore, x equals -1. As we mentioned earlier, number 7 is the other variety where we can go ahead and cross multiply to solve this. So I'm going to multiply the 3 times the 1 plus x, and that'll give me 3 plus 3x. I will multiply the 2 times the 1 minus x, so 2 minus 2x. Okay, I actually forgot to identify my restrictions. We know that x cannot take on a value of positive or -1. So go ahead and solve this, and so I'll get 5x equals -1, x equals -1/5. Okay, this is not a restricted value. Okay, so we're going to plug that in and check, and again, it works. All right, last one. So a couple things here. I'm going to factor x plus 3 times x minus 3. But what do we notice? We notice that, we've got a 3 minus x. So I'm going to take out the negative, factor it out, and then I can flip over my factor and write it as x minus 3. Now, I'm going to choose to take that negative sign and I'm going to apply it up in the numerator. So I'm going to move it up here and make that a -5. So I'm going to have 2 over x plus 3 plus -5 over x minus 3 equals 6 over x plus 3 times x minus 3. I didn't want to include it this time in my LCD. So my LCD is x plus 3 times x minus 3. And I know that x cannot take on a value of positive or -3. Okay, so let's multiply the entire fraction by that LCD. And first fraction, I can cancel out the x plus 3's, and I'll have 2 times x minus 3. Middle fraction, I can cancel out the x minus 3's, and so I'm going to have a -5 times x plus 3. And on the right, everything cancels out in the denominator, so I'm just left equal to 6. So 2x minus 6 minus 5x minus 15 equals 6. And looks like we have -3x minus 21 equals 6. So -3x will equal 27, and x will equal -9. Not a restricted value. I will plug that in to check, always going back to the original problem, and again, it works. So therefore, x equals -9. Okay, so that's solving rational equations. Next video is going to be on graphing rational functions.